All right, question 18. Samantha brought a block of land that is a composite shape. It consists of a square with an equilateral triangle on top. The side length of the square is 40 meters. What is the area of the block of land? All right, so we need to answer to the nearest square meter. All right, so how are we going to do this? Let's go with step 0 of my wonderful plan. So we're going to draw it. So it consists of a square with an equilateral triangle on top. So that means that side, and that side are all equal. The side length of the square is 40 meters. So that is our diagram. Okay. So once again, with this one, you're going to have area 1 and area 2. Now, I have a feeling that the problem with this particular one was in finding the area of area 2. In fact, what's the email said there? Okay, the square is 40 by 40. So absolutely. So let's have a look. Our area total is going to be area 1 plus area 2. So area 1 is a square, so it's going to be 40 times 40, which is going to give us 1,600 square meters. So that's good. Area 2, however, is this equilateral triangle. Is the triangle still half base times height? Yes, it is. It is still half base times height, but remember the height has to be the perpendicular height. Okay, so we don't have a perpendicular height here at the moment. So what are we going to do? Well, there's a couple of things you can do. Okay, I'm just going to throw some of them out there and we'll see how we go with it. If we had, say, exactly the same triangle on top, so we just joined it with the other triangle. Now it's exactly the same, which means that would be 40 and that would be 40 as well. But we'd have a rhombus, and we'd be able to actually go right. Well, my rhombus is got the same formula as a square or a parallelogram or a rectangle based on height. So it'd be 40 times 40, which would give me 1,600. But that's twice as much. So we'd have to halve that, which would give us 800. Okay. I'm just quickly scrolling around a bit on my other computer, which you can't see. Isn't that lovely? But that's not the way to do it, even though you could look at it like that and go, oh, I can work it out quite easily. That's not how we're going to do it. What we're going to do is we're going to use Pythagoras' theorem, and we're going to work out what the side of that triangle. I'm going to draw area 2. I'm going to draw the triangle. So here we go. Okay, so they are all 40 meters. Everyone happy with that? Now what I'm going to do is I want to work out what the vertical height is of that triangle. So I am going to draw, something's fallen there. I am going to draw that line there because that is my perpendicular height. That's the length I need to find. Now, because I'm going to use Pythagoras, I know that I've got c squared equals a squared plus b squared. And I'm going to go, well, this is my C, that's my hypotenuse, that's my longest side, and I'll call this A and I'll call that B. So I'm actually trying to find B. So if I rearrange that, I would have C squared minus A squared equals B squared, but I don't want B squared, I just want B, so it'll be the square root of C squared minus A squared equals B. All right, well, in this case, what does C equal? C equals 40 because it's the equivalent one. What does A equal? Well, A equals 20 because we've cut it in half. We've cut that triangle in half. So now I've got the square root of 40 squared minus 20 squared equals B. So if I chuck that into a calculator, now obviously you can't see what I'm chucking into the calculator, but I'm literally putting in square root 40 squared plus minus 20 squared, and that will give me an answer of 34.64101615. Okay, so that's 34.14, and I've forgotten the rest of the numbers. 64, sorry, 34.6410. So I'll go 6410 dot 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 because it keeps going on forever. Okay, so that's where we're going to stop at the moment. That is now that, and that is our height. So we've now got, all right, my base is 40 because that's from there, and my height, which we've just calculated, is 34.6410. Or don't forget, you can use the ANS button. So the answer button is still our friend. So in the calculator, I can put in half times 40 times ANS, and that will give me the most accurate answer. So I've got times 40 times ANS equals, and I get 692.8203. 692 point, forgotten already, 8203. 8203. Cool. I'm going with 4 decimal places just because I think that's accurate enough. So that would be my area. So now what I do is I then add these together. So my area total equals 1600 plus 692.8203, or I can now use the answer button for this one. So that is now, if I go in and go 1600 plus ANS equals 2292. So 2292.8203 dot dot dot, because I just like to indicate that it's going on forever. But then it asks us to do it to the nearest square meter, which means we went no decimal places. So that would be 2293 meters squared. And that's it. It was a little bit more complicated because you did have to find a little bit more information, but that's why it's question 18. Okay, so it was a bit of an extra step before we could get back to just doing our areas. But to find it, you just needed to use Pythagoras' theorem. So when you've got an equilateral triangle, you can cut it in half and you get the perpendicular there. And then we just used Pythagoras' theorem to find the shorter side, so not the longer side. So we weren't finding C in this case, we were finding B. Then when we had that, that was our perpendicular height, which we could put back into our area of a triangle and then add that to the other area, and we are done.